Oops. The rest of the day, we're going to do the test review. Okay. I wasn't recording, but once again, I added this. It is blank right now. It's blank, but it will be updated if we have a remote couple of days. Okay. And please don't get stressed like that they're going to shut it down until summer. That is not going to happen. It won't happen. Okay. So many people got this part of the test wrong, as in everybody. I feel like maybe we should do it together. All in favor, say sure. All right. Was this C3H6? Is that what it was? Yeah. Okay. So it was C3H6. All right. So C3H6 plus O2, did we already balance it together? Okay. Oh, Blaine, I cleaned out my million t-shirt stash. I forgot. I cleaned this out not very long ago. I had 38 shirts and jackets and hoodies all in that one closet. Okay. All right. He said he didn't have any purple. Okay. We already balanced it, didn't we? Okay. 2, 6, 6, and 9. Okay. I know. That's why I said we already did this yesterday. Then we already had it drawn, correct? So we had a double bond on one of the C's. Okay, so C, 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 and then the rest just octet them. Thanks. He's here. Pass that to Gabe. Why was that so hard for me to do right there? Okay, let me give you a warning. There was a few people that did math right and got 4046, but they were wrong. Do you remember why? No, because the answer, when you balanced it, was a 2, and the question said give it kilojoules per mole. So you have to divide it in half. Be really careful on the AP test that way. If it wants it per mole, it's got to be per 1 mole. All right. Anyway, here's our drawings. I squished this because I was an idiot. Let me just. I was putting O2s in 1C, or the other way around. 2 C's and 1 O. Okay, we good? The next thing to do is to like break every bond. So 1, 2, 3, 4, 5, 6. I have 6 CH bonds, right? Now, yeah, that's where I'm going right now. See this 2 right here? I'm going to put it right here, and then I'm going to do all of the crap, but I'm going to double it because it happens twice, right? Okay, then plus. Now, if you don't, you could have put 12 on the 6. It's fine, either way. All right, the next bond to break, I don't know, how about this one right here? Okay, so I have 1 C double bond to C bond. Are you okay with that? Plus, and there was just 1 C single bond to C. Okay, and then all of that would be doubled. We okay with that? Okay, it's gonna get tricky, so I'm gonna just group this all and shrink it. Okay, so that takes care of that piece of my, what do we call this? Anyone know? Propene. But you? Who said propene? No one said propene? It's propene. I swear I heard it because I wanted to hear it. It's propene.
We did. I said it actually.
Did you really?
No.
Oh. Okay. Plus, now I'm to here, so I'm going to put a 9. You all right with that? That came from here. And then really there's only 1. So are you okay if I put just a single O to O double bond right here? The 9 came from here. The 1 came because you only break one of them. You with me? Okay. Then my arrow. So far, okay? Okay, I have a 6 in front of CO2. So I'm going to bring that 6 right here. Then in CO2, I have 2 of these. 1, 2. C double bond to O's. A lot of you missed that. You put a single bond for CO2. And that hurt my feelings. Plus, we have 6 again. And then in water, you break 1, 2 bonds, 2, O to H. Okay. Then we plug in numbers. Whew. I'll distribute. So I have 2 times 6, which is 12. C to H, which is 413. Thumbs up. Have I screwed up yet? I'm pretty good at screwing up. Okay. Plus, I'm going to distribute. 2 times 1 is 2. C to double bond C is 614. Everyone with me so far? Okay, plus I'm going to distribute my 2 times 1 is 2. C to C, which is 348. There. And that takes care of propene. All right, plus 9 times the O2, which is 495. It is. And this is why everyone gets them wrong. There's just so much stuff. What's that? What if you have been right? You're golden. All right. Then I'm going to subtract 6 times 2, which is 12. Someone say wait. Okay. And then that's 799. Plus 6 times 2 is 12, and that's 463. And then I'm going to close that. All right. You guys disagree? All right. Blaine has a number. Broken minus formed. That's not what Blaine has. Blaine has exactly half of what both of you have.
And then I
What did I do wrong?
Wait, what do you have? What do I have? Okay. Okay. You tell me.
All right. Well, the answer is his second number, which is half of it. Okay. Raise your hands. We have negative 3809. Okay. That is the answer unless what? This is negative 389 kilojoules per every 2 moles of C3H6. Where does that 2 come from? Right here, right? So if it asked for it in kilojoules per mole, you divide it in half. And that's what Blaine had in his calculator. Okay with that? I did that math right. Yeah. Okay. This is on the test. Here, literally, I just looked at it. The only thing that changes is this number. This number. It did not on this problem. I'm just saying. Yep, I would take both these, by the way. But on the last test, it specifically said give your answer in kilojoules per mole. And on the AP test, it will. The reason why it will say that is because then you can use it in molar calculations. Sound fun? Because we can now say, hey, if I burned 100 grams of this, how much heat would be released? I could say if I burned 100 grams of this to heat 50 milliliters of water at this original temperature, what would it be its final temperature? Remember the calorimetry? It really all comes together in chapter 10 because we have moles. So any chapter where moles was involved, it can relate. All right, that's a good stretch. Oh, officially super old. Today I was walking up and I reached to open the door at the hall to come in for the day. And I grabbed the handle and I coughed at the same time and like blew up my upper back. I hurt my back coughing. It's time to retire. Okay, anyway, moving on. This will be on the test. Look at your person next to you and say, I could do this, or I'm screwed. What's what? Yeah, everything. No, well, it's not C3H6. Okay, well, I heard a bunch of talk. I heard one adamant redhead said we're screwed. All right. And one person said, is it the same formula? I said, no. She said, oh, crap. But it's the same process. It's the same process. It would be all this entire question. It says an unknown gas with a mass of yada, yada, yada is in a different volume, a different pressure, and a different temperature. But everything process-wise is exactly the same. Okay. These are from the practice thing. I'm not going to skip these. I want to make sure and do one that's exactly like the test. There's 3 big free response questions on the exam. That one, the one I've warned you for a long time, one like that, which we did twice in class. There's 2 videos on it and a 3rd video on the worksheet, the assignment that says whatever balance practice, you know what I'm saying, or not balance, Pivnert practice. Okay, so there's plenty of resources there. All right, are you looking for the muscle I pulled when I coughed? It's right here. It's like right here. Someone's got to know it. Noah. So it's called the WIMP. You know what you do to treat it? You take this medicine called Triactin. Triactin like a man, which is sexist. So how about I'll just change it to Triactin like a tough person. Okay, here we go. This problem is similar to the one on the test. I would just cut and paste it, but then it'll be exactly, and ain't no one got time for that. A container has 30 grams of nitrogen. How about, I don't know, what's your favorite number between 1 and 30? 17 grams. The one on this one doesn't do anything. 17 grams of, what's your favorite diatomic gas? Oxygen. And 1 gram, fine, of, what's your next favorite gas? Hydrogen, good choice. At a pressure of 2.98 atm. A, moles of each present. B, mole ratio of each gas. And C, partial pressure of each gas. Okay. Easy enough. Like, it's busy work, but this one's. Is that good, Davis? Okay. Did I just hear what I thought I just heard? They're all diatomic. Every one of them. All right, Preston, fire away. Oh no. We should listen to some tunes. I wish the sardines were on Spotify. All right, of my top 6 things at the top, that was redundant. We've got depressing 90s songs, Judah and the Lion, liked songs, Les Miserables, Your Artist Revealed, and then I don't even know what this is. My Beautiful, oh, that's Seth's song, My Beautiful Dark Twisted whatever. It's this thing. You'll recognize it. Yeah. The thing I play and no one hears. Seth shows it. Don't judge me. All right, I'm done with that. Okay, what did you want? Depressing 90s? There's some bangers. Someday. Preston requested Les Mis, so that's coming up after this. It's also depressing, and I think it's from the 90s. It what? Yeah, I'm not musically knowledgeable. Same thing. I'll go Les Mis right after this. Can you even hear the music, Preston? Play it louder. That would ruin the atmosphere. Oh, he can hear it. Never mind. The temperature doesn't matter because it would cancel out. Like it matters, but it's Pivnert 3 different times. So all that really matters is N. Partial pressure equals the mole ratio times the total pressure. Okay, does anyone need more time? All right. We're running low on time, so I bet I'll switch it over to Les Mis. What do you want, Preston? All right. Doesn't matter. It's harder to hear this one. It's kind of depressing. So it sticks with the depressing 90s vibe. Okay, who needs more time? That much more time then. All right, I'm moving on. Did I give you enough time? Oh, you didn't even need time to not understand what was going on. All right, that was kind of hard to hear. Sorry, Prowler or Preston. All right, we are back live on AP 2022 channel. All right, my friends, I had multiple people ask me, well, what's the temperature? You don't need the temperature. Like this is involving Pivnert of 3 gases, and you could do Pivnert three separate times, but the temperature is the same. So when you're comparing them, it would cancel out. The volume is the same, so it cancels out as well. It really only is dependent on the amount of moles. And we have the total pressure. So we have an equation that says that our partial pressure, so pressure of like gas 1, is equal to the mole ratio, or what was the other thing they called it? Molar fraction, the mole fraction, times the total pressure. So the problem is trying to set it up in order for you. So the first thing you would have to do is convert each of them to their moles, right? So N2 is 30, 38 or 28, right? 30, 28, whatever that is. And that would be roughly 1.07. Okay. Oxygen, you take 17 and divide it by 32, and that's equal to roughly 0.53. Okay. And that's for O2. And then hydrogen is equal to 1 gram over 2 grams, which is roughly 0.5. Are we doing okay so far? Okay, so hopefully easy money. We've been doing that for months and months. All right, mole ratio of each gas, you need to take each individual one and divide it like their moles over the total. So we have 1.57 plus 5.3 is 2.1. Is that right? All right, I'm gonna go 2.1 because I did it in my head and feel proud about it. All right, 2.1, 2.1. I put that as 3 separate denominators because I have 3 different gases. I need to take each one individually and divide it by the total. 1.07, 0.53, and 0.5. And that will tell me the mole ratio or mole fraction for each one of them. So B, I'm just going to bring it down here. What's that answer? 0.51, and that's for N2. All right. Was this O2? Yeah. O2 is equal to what? 0.25. Okay. And then N2, I just did, sorry. H2 was equal to 2.4 sounds good enough to me. That way it adds to 1. Because this should add to 1 every time. Okay. All right, now we're not done yet. That was the answer to B, correct? I just brought it down here for space. So C, the partial pressure of each gas, you now take the mole ratio. These things are the X, the mole ratios, and you multiply them by the total pressure. And the total pressure was given in the problem. It was 2.98. So for N2, it's 0.51 times 2.98. For O2, it's 0.25 times 2.98. And for H2, it's 0.24 times, I don't know why I did that when I did dots on the other ones, but you're going to have to live. And then we have the answers finally down here. Anybody? 1.52. And okay. They should add up to 2.98. And you know what? This one is that's gonna happen every time. Unless you're really bad at math. If these add to 1 right here, it's a little bit trickier to go through and make sure those equal 1. If those equal 1, you're probably going to be 100% right. Because you can screw up these numbers And you should still be able to get this to add to 2.98. But, okay, are we all right with that question? Okay, let's look at some weird multiple choice ones. Okay, this one is on the test, but it's more of a multiple choice than it is here. A mixture of gases contains 0.2 moles of that, 0.2 moles of that in a 4-liter. Oh, this is not what I thought it was. Never mind, it's coming. The one I want to talk about. It's this one. You'll see it has 0.2 moles and 0.2 moles. That's why I was confused. All right, this is nothing. I have no idea why it's there. So ignore this. A mixture of gas contains 0.2 mole, 0.2 mole. In a 4-liter flask, it reacts to form SO3. If the temperature is 235, what is the pressure after the reaction is complete? I guess it is the same, but I wanted to show you how it is math, but without a calculator. This is classic AP test question, because in the multiple choice, you can't use a calculator. So you're like, oh, sweet, no math. But there is math. So ask your partner, well, what would this be? All right, shouldn't be too bad. What two are instantaneously eliminated? D and E, because this 25 is not in Kelvin, is what I'm looking for. All right, then it gets tricky. Let's do it, because it's trickier than you think. The reaction's happening, right? The reaction happens, correct? One of them is completely used up. SO3 is formed. So you really got to do a little bit of thinking here. We had 0.2 and 0.2 and an arrow. We know it's going to make the same as the 2, right? So it's going to make 0.2. You okay with that? Which one's the limiting reactant? SO2. We're all right with that. So this goes to 0, doesn't it? All right, but we're only going to use 1/2 of 0.2 of oxygen. So how much excess is there? It'd be 0.1. So at the end, I have 0.1 and 0.2 present, which means how many total? 0.3. Does that make sense? You look at it and you're going to be stressed on the AP test. You'll be like, oh, that's not hard. It's 4. There's 0.2 and 0.2, but chemistry happens. All right. It's. Mm-hmm. Are we all right with that? No. Chemistry's not stupid. You are good at music. Yeah. Do you want to know something honest? Just, are we in a safe environment where I can admit some weaknesses? I had that wrong on my test for like 5 years. It was A. I never read it close enough. For probably 5 years, I screwed kids over. The smart ones got it right. And all the dummies like me, they were right. I'm like, man, why do so many kids? Oh, wait. I'm not perfect. I know I look like it, but. Thank you. Okay, we try this one, I mean. I pointed at that. This one's not as tricky. Does it say anything about a reaction? No. So do you need to do what we just did? Nope. You need to do what we just did. Who knew what I meant by that though? Yeah, the thing we did before the thing we just did. How come? I'm totally ignoring you. Yep. All right, who has an answer? Tell your partner so you're committed. All right. So who says A? Okay. Who says B? C, D, and E. All right, it's D. It's D. He gets all the answers from her. The silent assassin. She is a genius. And Devin's just looking all cool. He's like, I'm a Blaine, but really, when you look from the front, you know who's running the show. And Samantha loves attention, so she doesn't like attention. All right. All right. How are we doing? That can't be all of them. It was. But there's more. Let me just go through this. Don't look at the screen. You'll have a seizure. Don't do it. What the heck? I had a ton of these in here. Maybe I deleted them all. There we go. Here's some. Okay. Look at these two. Or ignore me at your peril.
Abby, he's talking about you.
Try them. I cannot believe how many people get this one wrong. And not just that, the top one. I can't believe which one of them they put down. It hurts every fiber of my being. I won't make anyone admit what they think the right answer is, because then you'll be like, oh, okay, he hates me. Okay, we'll find out. Okay, tell your partner which one you think it is. All right. Okay, Jackson. I'm not going to tell you the answer, but the one that is most likely not a gas is the one that's not a molecular compound. One of them is called an. There's molecular substances, and we learned how to name them, and they had weird names. And then there was another type of substance that we learned how to name. What? Oh, there's acids, but that's not what I'm looking for. Shoot me. Oh my. The answer that I'm looking for is ionic compounds. Oh, now you're like, I remember those. An ionic compound consists between two things, and they are a metal and a non-metal. Are they ever going to be gases at room temperature? Never, ever, 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 ever. They're not molecular substances. Molecular is like when two nonmetals are sharing electrons. I'm not going to tell you the answer to two. You can discuss it and look at it. It's not supposed to be hard. All right. You got an answer? Did you tell Blaine what the answer is yet? All right. We're not going to go over it. I hope if you don't know it, this is recorded. Look it up. You don't know what the answer is? I'm going to tell you a hint. If you don't know what the answer is, you have never looked outside the window during a major inversion. And that's all I'm going to say. It's too late. Seth was ruining it. You've never looked out the window during a what? Told you.
I was right. The answer is F, everyone. What is that?
Wow. Wow. It's almost like if you just looked at the same two questions, 3 different locations on the exam or on the notes. I wonder why. It's because people suck at them. Okay, hold on. Yes. I'm not going to tell you. Wouldn't that be nice if I did, though? Yep. No, Fruity Pebbles. You drop them, you're dead. Okay, here we go. I hate them. They're so messy.
It's okay, there's a cup.
All right. I'm looking at the actual test, which no one accessed. I just barely put a code on it this morning and no one had logged in and looked at it.
Because we're not cheaters.
One time I tried to. Well, I thought about it.
Okay. Here we go. One of them says the following. I'm not showing you the answers, but it says the following. A real gas. I'm not going to repeat it. A real gas will behave most like an ideal gas under conditions of blank. We went over that. Here's a question. It says, of the following gases, blank will have the greatest greatest rate of effusion at a given temperature. So it doesn't say why, which we stress because it's faster. So which would you be looking for? The smallest, and if there's 2 that are really close, the smallest and the least complex.
Wait, what was the question?
It asks which one has the greatest rate of effusion. All right, there is a question that says a gas originally at, and it gives you 3 conditions, and then one changes, and it asks for the new volume. What math do we use for that one? No. Okay, Blaine told her that time. The combined gas law, which I will give you. P1 V1 over T1 equals P2 V2 over T2. Does that sound familiar? You'll have the equation, but you need to know, oh yeah, that's the one I use for that. Here's a question. Which statement about ideal behaviors of gases is false? So what it's really saying is which of the things I'm saying next is a statement about a real gas. A real gas, I'm not even looking and I didn't look, but a real gas, the particles are attracted to each other. In a real gas, the collisions are not completely inelastic or elastic, okay, or they are inelastic. In a real gas, the particles do occupy some volume. So you're looking for one of those three things. Because in an ideal gas, all the opposite. There's no attraction between particles. The collisions are completely elastic, which means no energy was lost. And if I remember in my head the order I went in, the third one is we assume that the particles don't occupy volume. That's ideal. Real is the opposite. Then tell your partner under what conditions are ideal gases, do they become more like real gases? That question was terrible. But what conditions makes ideal become more real? All right. The last thing, we've gone over every single thing on the test, but one thing. One of the free responses is pretty short, but you have to remember, it says it's a gas collected over water. So it's a really easy question, but you got to remember to do what first if it's a wet gas. Subtract the vapor pressure from the total pressure and then proceed with Pivner as normal. Are we okay with that? Okay. I don't do it often, but I'm going to test you when we get back on Tuesday. So we'll be, if we get back. There's review stuff. There's the videos. In the last 2 days, I've gone over every single question math-wise, except for the one I just talked about. But it's a standard Pivner with a wet gas. So it's not rocket science. Go ahead. Oh. What? Probably. He's praying for quarantine so he can cheat. Yes. What? I don't know that they will, but just the COVID numbers are huge right now. All right, so remind yourselves, test when? Tuesday. Watch the last few days of videos if you need any help. Monday is Martin Luther King Day.